So we are going to talk about exponents in this video. So we'll go through the basic properties of exponents and then calculate these specific exponents that we have been asked to calculate. So these are some simple examples, but they will drive home the point of how to calculate exponents and what exponents mean. So in a nutshell, what exponents mean is, so exponents is a way of doing repeated multiplication with the same number. So exponentiation is an operation of repeated multiplication. Just like multiplication is an operation of repeated addition, exponentiation is repeated multiplication. So the first example, this is a simple one. So 2 to the power 2, which is basically 2 times 2. The number of numbers here is equal to this. This is 4. The second one is also somewhat straightforward, I would say. 5 to the power 3 or 5 cube, which is repeated multiplication of 5 with itself 3 times. This is the exponent, is equal to 5 times 5 is 25 times 5, which is 125. In the same vein, we have 3 to the power 4. Now we are going to use a property of exponentiation here, which is, it says, I'll write it first and then we can talk. 3 square square. So this is an important property of exponentiation, which is for any base a to the power p times q is equal to a to the power p times q. This is a property of exponentiation, which says that raising a given number to a large power can be broken down into smaller components here. So I don't want to raise 3 to the power 4 directly. So I'm going to write 4 as 2 times 2 and break down the exponentiation into 2 steps here that can simplify the operation. So because the inner operation is basically 3 times 3 and the outer operation is the square operation, which is 9 square, which is 81, which you can do even doing the straight multiplication of 3 times 3 times 3 times 3 as well, but we are going to use a trick here or a similar simple property of exponentiation. The fourth one is somewhat tricky, but we can talk through it. 7 to the power 0. Now any number to the power 0 is 1, but let's see why that is the case. So here you can think of 7 to the power 0 as using another property of exponentiation, which is, so I'm going to write the property on this side. A to the power p minus q is equal to a to the power p divided by a to the power q. This is an important property of exponentiation, which says that raising a number to a power can be thought of as raising it to one power and then dividing it by another power, so that the difference between those two powers is the original power. So you can think of this as 7 to the power 1 minus 1, which is 7 to the power 1 divided by 7 to the power 1. You are dividing the number by itself, so the answer should be 0, or rather the answer should be 1. Or there is another way of looking at it for those who know that the empty multiplication is 1. So multiplicative identity is 1, and it's like saying that I'm multiplying with no numbers at all. It's an empty multiplication. So 7 to any number a to the power 0 where a is non-zero is equal to 1. It's like saying this is like empty multiplication. A similar analog of this would be an empty summation, where empty summation is 0, because 0 is the additive identity, 1 is the multiplicative identity. So just like empty summation or empty addition is 0, the empty multiplication is 1. So this is important. A to the power 0 is 1 if a not equal to 0. Even if a is equal to 0, the convention in most of mathematics and combinatorics is that 0 to the power 0 is also taken as 1, but it's not as clean. It's a degenerate form. I think this video is we need more deeper discussion before we can talk about 0 to the power 0. This video is not the appropriate forum, but remember that a to the power 0 is 1 whenever a is not 0. All right.